going to be using table A2 again to calculate probabilities. The only difference between this section and the last is that we're going to be calculating our own z-values given a mean and a standard deviation. For example, IQ scores have a normal distribution. The mu is 100, sigma equals 15. Now find the probability a person is going to have an IQ under 120. So draw the normal distribution. Notice that the mean equals 100 is in the middle. The score of 120 would be over here at the right. And then the shading would be under that, so it goes to the left. It's all of this. Next up, we do the z formula, and we end up with z equals 1.33. Then get table A2, the positive z-scores, and just look up 1.33. Also notice that this area matches this area. So whatever answer we get from this table, that's going to be the final answer. So look up a 1.33, and that is right here, a 0.9082. And that's it. That's the answer. Again, I'm using this example of IQ scores. This time though, what are the chances, or what is the probability that a person's IQ would be between 105 and 117? So here's what the picture looks like. We've got in the middle of the picture, again, the mean equals 100. Just to the right of that is 105. And then we need to do the z formula. We end up with a 0.33 there. Over here is the 117 with the shading in between the two. Do the z formula, we get a 1.13, and now we need table A2. So I am going to look up this one first of all, that z equals a 1.13. And that is right here, it's an 8708. Now an 8708 would go from the z equals 1.13 all the way to the left forever. So the answer that I got, the 8708, is way too big. You can see that this does not go way to the left forever. It in fact stops right here at 105. So we then need to look up the probability for this z-score, and we're going to have to subtract the two answers to get this small area right here. So now look up a 0.33. That's a 6293. And then subtract the two answers, and we end up with this small shaded area, which is about 24.2% chance. And another one with the IQ scores, the same information, but this time what's the probability that somebody has an IQ under 88? So draw the picture. Always have the mean in the middle. Then we do the z-score. And it turns out because this score is on the left, this is then a negative. So this time we need table A2, but the negative z-scores. So look up a negative 0.80, and that's going to be this one right here, 0.219. Oh, that's supposed to be 2119, sorry. 2119. And then here's a different example. So now we're going to work backwards. So on the previous ones, you're given the score and you find the percent. Now you're given the percent and you need to find the score. So first of all, draw the picture. This is what it would look like. The mean equals 80, goes in the middle. Here's the top 10%, which means that they beat 90% of the other people. And then we need to find the z-score. So remember, this is when we use the table and go backwards. So you search the table and find what's closest to 90%. It's 90% because this is the left side of the graph, and that's what this corresponds to. So you have to look for what's closest to 90%. And I found it. It's right here. 8997. So then go backwards. That's going to be 1.28. So z equals 1.28. So for one, I would appreciate if you put on your paper that that's what we used, an 8997. That gave us a z of 1.28. And then this is the formula for the score. So this is basically coming from the z formula, except you take the z formula and you solve for x. So that means it's going to be the mean plus the z times the standard deviation. And when you do all of that, you would need to have a 95.36 in order to be in the top 10% of this class. Or sorry, that calculus class, not this statistics class.